This is the final video for section 3.1 in the textbook, and it will discuss reciprocal trig functions. Now, we already talked about sine, cosine, and tangent, and we said that sine was the opposite side divided by the hypotenuse, that the cosine was the adjacent side divided by the hypotenuse, and that the tangent was the opposite side divided by the adjacent side. Now, anytime we take a reciprocal, and this is where we need to be very careful, reciprocal means that we flip the fraction over, and that's all it means. It doesn't mean inverse, it just means reciprocal, flip the fraction over. So the reciprocals to these functions, these are ratios, so we can flip these fractions over, are going to give us these three new trig functions. Cosecant is the reciprocal of sine, so this is going to be the hypotenuse divided by the opposite side. Secant is going to be the hypotenuse divided by the adjacent side. And cotangent is going to be the adjacent side divided by the opposite side. So we can also write this, and we need to be very careful, that cosecant is the reciprocal of sine, so we can write this as 1 over sine of theta. And the theta goes with the sine. It does not go outside, it sticks with sine, because that is the operation on theta. Likewise, secant is the reciprocal of cosine, so this can be thought of as 1 over cosine of theta. And cotangent can be thought of as 1 over tangent of theta. So take a second here, make sure that everything makes sense. Again, these are reciprocals. All they do is flip their fractions over. They're still trig ratios. They're just flipped over trig ratios. The one other thing that I want to talk about real quickly has to do with the fact that if you notice here, tangent is opposite over adjacent. Well, that's really this numerator of sine and this numerator of cosine, with essentially if you had divided these two fractions, the hypotenuse would cancel out. So another way that we can think about tangent is being sine of theta divided by cosine of theta. And again, we need theta with both of those because the trig ratios are just functions. They don't mean anything unless you have an angle to operate on. Since cotangent is the reciprocal of tangent, we can just flip this ratio over and know that cotangent is going to be the cosine of theta divided by the sine of theta. So again, those are two other helpful identities when we're given certain information and need to find the remaining trig ratios. So, for example, if we are given that sine of theta is 4/5 and cosine of theta is 4/5, we want to find the remaining 4 trig functions. There are two ways that you can do this when you're given two pieces of information like this. The first thing you can do is you can just go through and set up your right triangle. Put your angle down here in the lower left-hand corner and say that, well, if we know that sine is 4/5, well, opposite to the angle is 4, hypotenuse is 5, and if cosine is 3/5, well, then the adjacent side is 3, and we already said the hypotenuse was 5. And then we can go through and find the remaining trig ratios. Another way we can do this, and I'm going to just list all of these, we already know that sine theta is 4/5, that cosine theta is 3/5. So using this triangle, we could deduce that tangent of theta will be 4/3, or we can come over here and look at this identity that we were given and say that this is going to be sine of theta, which has a value of 4/5. We don't put the angle there, we put the ratio, divided by the cosine, which is 3/5. Now, if you remember how to divide fractions, you know that this is 4/5 times 5/3. That 5 divided by 5 is 1, and you are left with 4/3, which is what we said it should be, opposite over adjacent. Now that we have sine, cosine, and tangent, we can find the remaining reciprocal trig functions, namely cosecant of theta, always make sure you have theta, is going to be the reciprocal of sine. So this is going to be 5/4. We just flip that fraction over. Secant, which is the reciprocal of cosine, is going to be 5/3. And cotangent of theta is going to be the reciprocal of tangent, which would be 3/4. Now this also lines up with our definitions up above. Cosecant is the hypotenuse, which was 5, divided by the opposite, which was 4. Secant is the hypotenuse, which was 5, divided by the adjacent side, which was 3. And cotangent is the adjacent side, 3, divided by the opposite side, 4. So these would be all 6 trig functions for this triangle. We're going to try one more example, and this one deals with decimals, which you may think is a little bit trickier, but if we just use the same process up above and we don't necessarily rely on the triangle, we can get through this relatively easily. So since we know sine is 0.8387, I'm going to rewrite this here. Sine theta is 0.8387. Cosine of theta is 0.5446. Then we can find that tangent is the ratio of these two numbers. It is 0.8387 divided by 0.5446. So if you do that calculation, you should end up with 1.54 approximately. So we'll use our approximately symbol. Now I want you to pause the video at this point and find the other 3, the reciprocal trig identities. So you should have found that since cosecant is the reciprocal of sine, we would do 1 divided by that decimal. Since the other ones we could flip the fraction over, this is a decimal, technically this would be thought of as being over a 1, so we would flip that over to find the reciprocal, which is 1 divided by 0.8387, which is approximately 1.192. Similarly for secant, we would take the reciprocal of 0.5446, and we would get 1.836. And for cotangent, we can either take the reciprocal of tangent, or we can take this as being cosine 0.5446 divided by sine 0.8387. Either way, you end up with the same decimal approximation of 0.6494. This concludes the lesson for 3.1. Please go online now and complete your homework for this section.